All right, good afternoon. My name is Joachim Hammer. Welcome to our session on Azure SQL Database Managed Instance with a focus on security, of course. And I'm here alongside my colleagues, Ajay and Surjan. So the three of us will lead you through our program. Hopefully it's going to be interesting and informative for you. We'll hand over a few times back and forth, but we've got a few slides to motivate the stuff, and then we have plenty of demos. So,
and we'll have some time for your questions.
That's right. So we're trying not to go too much. All right. Like I said, we're going to focus on security, which, of course, is always on the top of mind, especially with managed instance. And so before I launch in, I'm just going to quickly recap a 101 on what is managed instance, how do you position it. So overall, we have Azure SQL Database, of course. That's our family of PaaS services. And in this family, we've always had singletons, we've had elastic pools, and now we're super happy. We've added managed instance, and that, of course, is to close this gap for a lot of our customers, enterprise customers, wishing to move applications into the cloud with minimal effort without having to rewrite a lot of things. So we've enabled surface area. We've added additional security that was important. So we've got these three offers. And you'll hear a lot about this. I'm just going to quickly go through here. When it comes to security, the message from our side is we've got you covered. We have essentially the same security that we have for Azure SQL DB for the other two offers. There's a few things that we're still working on. And materially, we also have additional capabilities that are not yet available in SQL DB. Most importantly, of course, VNet support, which was something that just had to be there given the architecture and the intent of managed instance. So full isolation, a lot of security features, and you'll hear much more about that today. Oops, didn't mean to. And then, of course, I mentioned it already, compatibility. This is something that we were aiming for. This is something that was really a gap for a lot of you guys. It's still managed, so I think there's always this little bit of confusion where folks look at it at a glance from very high level and say, well, this is just like a VM, SQL in a VM. Well, it isn't. It is really the surface area, all the features and capabilities that you would get if you ran SQL in a VM, but it's a managed offer. And again, we'll come back to that in a little bit. And then, of course, you're all familiar with our new business model, the a la carte model, where you can basically configure your instance, your databases across a variety of dimensions, the vCore model. And again, this also adds to not only the competitiveness, but also the friction-free migration. So enough of the intro. Let's dive right in. So the way we've organized this session is along the layers that you're probably already familiar with if you've attended a few of our security sessions over the years and months. Physical security, we just put that there for completeness sake. When you use any Azure data service, of course, you get a full complement of protection, security guarantees, installations, things like physical protection of our data centers and so forth. We're not going to cover that here. We just assume that's there. If you're interested, there's a whole lot of collateral on the various Azure websites. So this session really starts with the network security layer, and then we'll just peel away these layers of this onion. We'll go down the network. We'll look at talk a little bit about the isolation, the underlying security architecture, talk a little bit about authentication, especially Azure Active Directory authentication, of course. And then we have access management, and here, as part of this, we'll also talk about encryption, the same kind of protection that we have for data that you've enjoyed in SQL DB. So we'll have a little demo there, and then threat protection, and then we'll wrap up. So that's the overview. And I think without further ado, I'll hand it over to Surgeon, and he's going to go deeper on the network side.
Thank you, Joachim. So I will add a few words about network security and cluster security. And these two rings, from how we call it, often security onion, they're very close together because this is where our customers and we meet together to provide additional security for the managed instance. And that's what's a key differentiator from the security perspective between Azure SQL Database Managed Instance and Azure SQL Database and Azure SQL Database Elastic Pools. And before going a bit deeper into kind of network security, I would just like to explain a bit about the communication channels and the traffic that goes in and out of managed instance, so it would be easier for you to understand our network security requirements. And then we will also go deeper at the cluster level through our secure architecture to enable how our secure architecture actually complements our network security requirements. At the beginning, you have managed instance that is inside your VNet and your application and tools here. And when I say inside the VNet, I really mean a hybrid network. So it could be virtual network, it could be peered virtual network, it could be on-prem network that is connected via site-to-site VPN or express route, or it could be some other VNet paired with express route circuit. And also we support connectivity through point-to-site VPN. So on this diagram, when we say we are in the same VNet, we just do not assume like just Azure virtual network, but your network that extends to the cloud. But besides this traffic that goes from your application and tools to managed instance, there is also traffic that is used for actually managing the managed instance. What's inside your VNet? It's our cluster that is a hosting platform for SQL Engine. But there are other things that we use in order to provide that. For the general purpose tier, we use Azure Storage to keep your data and your backups. Also, we could reach out from managed instance to Azure Active Directory to provide authentication, especially in some scenarios where groups are included and some metadata from Azure Active Directory is needed to do the authentication properly. And of course, we use event hubs for all the telemetry, billing, and all other stuff. So managed instance needs to reach out to these Azure endpoints to provide all these services. And here is our control plane with management and deployment, automation, as well as machines, dedicated secure machines that are used for maintenance. And some of this traffic, as is shown on the diagram, is bidirectional. So there are situations where managed instance actually needs to reach out that management and deployment plane, because some of our objects, like managed databases, that are databases kept in the managed instance, are actually objects that are in ARM enabled. So when you create the database on managed instance, you need to also notify the ARM layer about it. And there even a scenario when we reach out to the internet, and this is thus limited scenario where we reach for certificates to do the verification. Why is that? Actually, all this communication, when I say all the communication, I mean really all, so communication between managed instance, control plane, Azure services, as well as communication that is trusted and encrypted communication that comes from your side to the get data and do the T-SQL. Actually, all that is TLS encrypted. And that's a part of our encrypted in motion promise to you. And in order to be actually safe, we need to do this certificate verification to see that to make sure that none of these certificates are expired, and for that we need to reach out to certificate authorities. We heard from you that although this kind of traffic is understandable, that it's kind of preferable if it does not happen. So we are thinking about other ways to solve this dependency and do kind of external certificate verification. And for that, I would go to kind of what is enabled by this infrastructure where managed instance runs in your virtual network. And that's actually, you could fit the managed instance in your own secure network architectures. And what you see on the screen now, this is the hub and spoke architecture. That is the most common architecture among our customers, where actually the customers often have, if they have multiple regions, they often kind of put this hub and spoke in each region and then connect to on-prem and between the regions using express route circuit. So one of the most common questions coming from you is, okay, in this architecture, where could I put the managed instance? And having in mind that managed instance is shared resource, it often goes to hub. But what we seen, and there are also scenarios where managed instance could go into one of these spokes where actually that spoke presents hub for itself and for its workloads. But either way, you have all of these network security configured, so you could actually make sure that only from subnets that need access to the managed instance, you actually get that access. And now to kind of make it a bit more interesting, I will show you actually how you could configure this virtual network for that access. So I will just quickly switch to my laptop.
Do you want to switch over here?
Yeah.
You are 7.
7. Right. Good. And now what you can see on the screen, I will zoom up a little bit. What you can see on the screen, this is that virtual network, and you can see the subnets. This is our hub network, and you have managed instance subnet among all of these subnets that you usually have in your spoke. So now we will, in this scenario, I will be kind of IT guy that needs to configure it in order for managed instance to be deployed. And I have to take care of all these ports that need to be open in order to communication that I previously explained happens. So let's quickly go to that network security group. And I'm going to this network security group that is what I can see from here from the portal associated with subnet that I need. And then I could actually see these rules. I set up the rules. I want actually marketing apps to access managed instance. But yes, I need still to get these ports and all of these figured out. So I go to our documentation and say, wow, there are a lot of it. So should I configure all these things manually? But fortunately, the answer is no. We kind of, in order to help you, we kind of provided in our documentation a PowerShell script that you could figure. It's actually the script is quite simple. You need just to put on it a few parameters like subscription ID, resource group name, and virtual network name. So, and then the script will go through it and give you some results and ask you if it's okay to update the subnet and then update. And I will show this through this short demo. Okay, let me just run the script. And I will just go slowly through this script. Okay, one part of it kind of already finished. But this is the things that script will do. It will check if a user is already logged in, if appropriate subscription is selected, or select the subscription. Make sure that info about that virtual network is loaded. Then check if the subnet is of appropriate size. And I would like to now talk a bit more about this, about the size. So actually, managed instance is a cluster of nodes. And I will show that cluster up front. So you need to make sure that you have enough size and to plan the size up front. So when you need to scale your managed instance or add additional managed instances in your subnet to make sure that it will fit into it. And we also in our documentation kind of have recommended sizes, and this script will also advise you if this subnet has enough size or it's a minimal size, or give you kind of guidance in that aspect. And it will also check for the DNS server. Currently, we ask you to put, you could use custom DNS servers, but we ask you to add Azure DNS at the end of the list, because managed instance actually uses all these settings that are on the VNet level. So we want to just to make sure about that managed instance will be able to resolve all these FQDNs that is needed for its proper functioning. And in future, we are thinking about how to remove this limitation. The similar thing is with service endpoints. And then we come to network security groups, as well as route table. It kind of gets into it and provides, just give me a second, and it provides things that needs to be changed. For example, it detected that these ports need to be open in order to make sure that all the proper communication could happen, and then we could say yes. And after that, the script will keep running and make actually the copy of that network security group, add additional rules into it, and replace it on the subnet automatically for you. While this script executes, I will just kind of want to switch to the slides, switch back to the slides, and speak a bit more about it, and then eventually we will see what script did. So it's 6.
No, it's here.
Yeah, good. So the other thing that we often get a question is, okay, I'm using this three-tier architecture, so what is the best way to modernize the center and move to the cloud? And of course, we could map this easily to the cloud solution with managed instance. So now we see Azure Application Gateways, load balancer, web tier, managed instance in its own subnet with secure jump box here. And instead of using Azure, instead of using Active Directory, managed instance will use Azure Active Directory for authentication. And you will see in later lectures how actually you could achieve the same scenarios, the same integrated out with managed instance as well as you could do now with Active Directory. And now I will switch back to my laptop, although I have some kind of connectivity issues, but hopefully I will be able to show you this network security group that is created. Here is the one that gets created. You will see actually all these rules with prepare prefix that are added to the network security group, and you will see that this network security group is now associated with managed instance subnet. So with these few simple steps, you could actually prepare your to your virtual network subnet to host managed instance. With that said, I will hand over to Joachim for the next part.
Okay. Actually, one more.
Actually, that's
no problem. Okay, so yeah, so these network configurations, they are complicated, unfortunately, but with scripts like what Surgeon just showed you, do you want to actually talk about, you have the next section still.
Oh, yeah.
I was wondering why you're handing it over so fast. But anyway, so the script that Surgeon is building, and he continues to build more scripts. We're hoping to make the whole, the initial configuration a much lower barrier of entry for folks like you. So
yeah, thanks for that.
No problem.
Brief. Yeah, they are available at documentation. So, and I will just kind of, and these scripts are given, I will just kind of comment a bit on it. So they're kind of given in this simple format, where actually you just set up the parameters, and actually the script itself is downloaded from the GitHub repository. And there are a lot of scripts in these SQL samples. Some of them are about management. So you could actually, if you're in kind of, you could use that script as the starting point, adjust to it, and actually include this script in your CI/CD pipelines or automation things. So we provide both like this for the guys who just want to simply configure parameters, and for those who just want to make this more complex setup, we could provide this guy.
we'll put the GitHub repository in the slides, so when you download them, you'll have it.
Sure. So let's explain now in a bit cluster security model. So as explained, we have a VNet, and the whole cluster is in the VNet. Actually, to be more precise, it's on a subnet level. So if you have multiple managed instances and multiple subnets of your VNet, you will get multiple virtual clusters in there. And that's good. If you need some kind of tenant isolation for different kind of workloads that require different security contexts, you'll actually get this guy. And regarding the traffic, with red, we kind of depicted on this diagram that a data path, actually. It starts from load balancer. It's internal load balancer that has private IP address from your private IP address space, and it routes traffic through the gateway, and gateway nodes are where authentication happens. So you could make a secure connection to the SQL engine. And what is zoomed out in this, zoomed in at this diagram is one of the nodes. It's primary node. Because the cluster has multiple nodes standing in to ensure high availability of the cluster, and one of them is kind of primary that takes workload in certain point in time. And that pathway goes to the engine. And we have this management part of the service as well. And this management traffic goes to the SQL management endpoint that has a public IP. And this is where a control plane and deployment automation connects to in order to manage the instance. So one thing that I would like to point out here is that none of these nodes are exposed with a public IP. So the traffic goes to the load balancer. And the load balancer is configured in a way that just through these 5 ports that are used for management actually goes passes the traffic through. So when traffic passes through the load balancer, then it goes through the Windows firewall. So actually, all of these nodes has a Windows firewall that is configured to allow traffic to just of dedicated ranges. And then that is from the network security level. And then on the application security level, we have multiple certificate authentication between the caller and that is called application that is called SQL management node agent that is actually doing this management. And I would like to emphasize here just that we could see here that virtual cluster, it's not kind of about like SQL Server installations and PowerShell scripts on top of it. It's really cloud-native solution with different apps, very similar to microservice architecture, where these apps are actually hosted on the cluster, separated between themselves, and secured properly. So with this, I will now handle the Achim.
All right, I'll take it this time. Are there any questions so far? We can.
Yeah, so I would also explain this. So we are regarding Azure Key Vault. That is something that is coming, and of course, when if you need some additional features like the connection to Azure Key Vault, you will need to enable to open additional ports to enable that communication. But for the Azure Key Vault, I think it will go over for free as well, similar to Azure Active Directory or storage. Yeah, Joachim will talk a bit about authentication. So we support Azure Active Directory integrated, and you will see a demo. I do not want to kind of make spoilers.
That's okay, yeah. We'll talk about that in a few minutes. Anything else on network stuff so far? I know it's complicated, but and will be available afterwards as well. So, but feel free to raise questions. We don't want to just talk here. It should be interactive as much as possible. Okay, we'll pop up a level and let's talk a little bit about Active Directory, and I'll just go through this quickly. So, why Azure Active Directory? Well, there's a couple answers here, a couple reasons. Most importantly, it's a single point of management for your identities in the cloud, and this is what Azure is embracing. And so it helps you manage your users and passwords. In some cases, you can even avoid passwords, which is actually a direction that we're slowly in SQL moving towards. We want to get rid of passwords as much as possible. So there's different kinds of authentication. There's token-based authentication and so forth. But essentially, think of it as this one place in the cloud where you manage your identities. And from there, you can then start accessing all the different Azure services without having to sort of keep track of different users and different passwords for every service we have. Simplified permission management, I'll show that in a little bit. By doing this in Azure, you can then have, you can create groups, you can create users, and these groups can have various permissions. They can be tied to permissions in your local services. So for example, in SQLDB, we can have Azure, an AAD group that's associated with a group or user in SQLDB, and you can manage permissions inside SQL through these groups and users. We talked about the elimination helps you eliminate passwords. Another very big sort of step forward was the introduction of MFA, of course. So that's supported in Azure-wide in AAD and in SQL, including SQL Managed Instance as well. So that provides an additional layer of protection, and you can configure that in a variety of ways using conditional access policies, and I'll show you those as well. That allows you to basically enforce MFA policies either on users, on groups, and you can also enforce the different IP addresses, devices that need to be that users can connect from, and so forth. So overall, an extra layer of security, and the last on this box on the right-hand side, lower right-hand side, indicates that it's a little bit of work in progress for us still. So we are supporting MFA specifically in a variety of tools and drivers. We haven't finished quite yet, but and if there's anything that you feel is missing, always let us know, and we can give you an update on what's coming and what is in the works. So that's a quick refresher on AAD, and let me just give you a demo here. I'm on 6, I think. So I'm going to log into a VM, and sort of think of this VM as my domain joined machine. And so now I'm in here, and we have this. We've created this domain AAD SQL MI. So this is fictitious organization, and so I'm on my machine, and I'm going to log into the portal now, and takes a second or so. So here I am now. Correct. So think of this as for this AAD, SQL MI. This is a Windows domain that we have created here, and what we're showing now is how you can actually sort of recreate that kind of behavior that you get on premise in the cloud, single sign-on, MFA, and so forth. So I've authenticated to my machine or this VM, and now I open up the portal. You notice I didn't have to authenticate again here. And so in this portal, let me show you a couple things. So first of all, let me show you actually what happened there, who this user is. So we can browse over to the Azure SQL Active Directory portal, and under users, actually, so here are a couple users with my name, and this is the one here. That is right. So I'm Windows Server. So this is actually a Windows Server AD account. This is basically, think of it, we federated our on-prem AD directory with the cloud, and so I'm in there now as a cloud, as a Windows AD user. Okay, and I have portal permissions, so I can browse around the portal, and if we come back, let me show you a couple other things that we need. So for example, here we have a managed instance, and of course, in order to manage this instance, there is always So in addition to the SQL admin, there's an AAD admin that you can set. And in this case, this AAD admin is a group named managed instance users. And so, oops. So if we browse back over to Azure AD directory, we should be able to find this user, this group, and down here it is. And so we can look in there, and there's a number of users, and so this is an example of how you can basically manage this instance here. So there's 9 users here. I'm not going to go into detail there. There's one more thing that I wanted to show you, namely there we created another group called a guest group, and this guest group has 2 members, and we'll use those members in a little bit. And so these are the other 2 Joachim users that you saw earlier. One, and these are guest users, invited users. So this is an example of B2B. So one is a Microsoft account, and the other one is an MSA account, an Outlook account. And then last thing I wanted to show you here is coming back up. Under conditional access, we've created a few policies. So there's an admin MFA policy, and this policy basically specifies an MFA policy on our managed instance users. The only thing that you notice, though, I don't know if you saw that here quickly, is that it's currently disabled. So if you look over here, that policy is not enabled. And then we have one more, and this is a JGuest policy. And so this basically enforces MFA on this group JGuest. So later on, if we were to log in with a member of this group, you'd see there's an MFA policy in works, and we would have to provide a second factor.
And I would like to add on top of it that managed instance group actually is group that is in from the Windows Active Directory. So from that point of Active Directory, all the management is done on-prem. So the Azure Active Directory is used to federate it and to actually connect Active Directory that is on-prem with cloud resources to achieve all this stuff that you have on-prem. So. Yeah,
that's right.
Yeah, that's right.
So the only, thank you, Surgeon. The only one, the only identity that was there that was federated was the one that I logged in earlier. That was the Joachim Hammer at AAD SQL MI. That was the Windows where you saw Windows Server AD. That was a member from my on-prem act that we federated into the cloud. And so with this, now I should be able to, if I connect now, I can connect to this instance here, and I'm going to choose integrated authentication. And here's that Joe Hammer user again, and so I should be able to, and there we go. So now I've connected to our managed instance. Again, didn't have to provide a password, and so here we are logged in. Now, this, as you notice though, this user not only is, it was a federated user, but it also has additional privileges in the database. So it's not a member, it wasn't as additional capabilities. So if we look at server roles here, you will see that this user, for example, can be a member of some of these fixed roles. So in this case, there's a security admin role, and here you go. So this user now has additional privileges inside our managed instance, and there's a few other roles that are there. And this allows, for example, this user to do some of the security administration, for example. I'm going to disconnect here, and I'm going to do something else. I'm going to connect now using one of those guest users, specifically the Outlook, the MSA account. And for that, I'm going to use universal authentication with MFA. Here's the Outlook user that was in the JGuest group that you saw earlier. And so if I connect now, couple of things should happen. First of all, it'll ask me for my password. And then, since remember we had an MFA policy on that group, I have my phone here, and so an additional code is coming to the phone, and I have to type that in, and that gives us the second factor. Okay, so now I'm in. So now I'm authenticated again to that same managed instance. Now, in addition to that, there's actually a login created inside the managed instance for this particular user. And with this user, so for example, I now have, we've given this user admin privileges. So let me show you that. So here I am. So in addition to some of these others, here's my Outlook account now, and this now has admin privileges on the instance. So I can do things like let me open up my script here. So for example, I can go and run cross-DB queries, for example. So with this user, I can now, so there's, actually I forgot to show you this here. If you look over here, we have a number of databases. Oops, and there's, sorry about that, worldwide importers, for example. And so as Outlook user, I have privilege. I can query cross databases. But that's not the only thing I can do. Let me do one last thing. Whoops. What happened here? 1 second, sorry. So let's do the following. Let's actually create another user from this login AAD SQL MI that I've showed you earlier. This is the one where I signed on through, was also a security admin, in unmanaged instance. So let's create a user from that login there, and then we can show you a couple other things. Actually, before I do this, let me show you a quick app that Surgeon has created. And so the scenario here is, let's say we're on-prem, we have a database on-prem, and we're migrating this database into the cloud now. We're putting it into a managed instance. How do I ensure that my authentication works seamlessly? How do I make this happen? And so with this app here, we have, as you can see, the connection string here. Basically uses integrated security, and we're connecting to a database that's on-prem. And if you look at, this is just a very simple app that shows a bunch of to-do items on a to-do list, okay? So let's say we've migrated this database into managed instance already. And so what I want to do is I want to change my connection string, and I want to connect to this app that's in managed instance, which you can see over here. I forgot to show you this. Now, of course, it generates an error because there is no user yet in this to-do app. So the user that I've used to connect on premise doesn't have privileges to connect to the to-do app in managed instance. And we can fix that. There we go. So let's do this. So in this to-do app now, I'm going to create a contained user based on this login. And then I'm going to add a few privileges to that user so that I can actually read the database and write into the database and so forth. And I'm going to do this as this Outlook user that we've looked at earlier that is sysadmin on this managed instance. Okay? So if I look at the principles now, you will see that here is, in this database, in this to-do app database, here is Joe Hammer. Let me just make it a little bigger. There we are. And it show up as an external user. Okay? So now with that user in there, if we go back to the app, and I click to change it to SQL MI, and I now look at my to-do list, there it is. So the database was migrated. I created this contained user in the database, which was based on a login, which is based on a on an AAD identity that we had federated earlier, and so the whole story hangs together and works. Okay, so just a glimpse into what you can do with AAD, Azure Active Directory. So what we did was, quick recap, we have Windows AD on-prem. You can federate your identities in your Azure Active Directory. And then from there, you can start, you have your AAD admin group that gives you administrative rights in the control plane. You also have the abilities to create databases. And then from there, you can then start creating either contained users or, and that's new where it's actually under preview, in managed instance, you can also create logins that are based on these AAD identities. So both are possible. So once you have your identities in AD, you can then map them either to contained users or logins. The power of login, of course, gives you all these capabilities that you're familiar with from SQL Server on-prem, like I showed you, running cross-DB queries, agent jobs, and so forth. All of these things are possible.
And one thing that is very nice about this, so what we try to illustrate with this app, that actually you have some kind of legacy Windows Forms app that uses Windows out. So you could see that with just connection string change, you could have all that same integrated authentication experience on managed instance as well. And furthermore, this actually the reason why we choose the to-do list as application of choice is because of row-level security. Because we implied row-level security on top of it, and that identity propagated through the database to provide the to-do list for each of our Windows users that are now federated to the cloud.
Very good. Okay. What's next?
We have a question.
Yes. Sorry, is there a way to mimic? Yes, absolutely. The only reason that external user was so powerful because we added all these permissions, but by default, you can control this, what I said earlier, what this permission management. We could have just left this JGuest group just to be, we can make them to be contained user in a database, or you can pretty much limit their permissions to anything you like. They could have just been data readers. You could have made them backup group. I associate that with a user group. I associate that with a user contained 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 user. At that moment, the only privilege that members of that group have are connect privileges to the database. So that's how it starts off. And then from there, rather than taking things away, you have to add things. Otherwise, the only capability for this JGuest users were, I can connect to the database, but that's it.
You do not have to use federated users with managed instance. You need to configure it explicitly. By default, it's not configured. You add.
Okay, so actually, let's continue here. Let me close this my session here. And do we have any slides here? I forgot, actually. Yes, so let me just quickly, you probably heard a lot about monitoring, threat detection, vulnerability assessment, and so forth, so I don't think I have to go through a lot of the details here. Let me just say a couple of words quickly. So threat detection, of course, works in managed instance. It's the ability to detect unusual capabilities. We'll do a quick demo in a second. The other interesting sort of development or announcement that we've made this week here, we'll talk more about it in the following session, is that, again, auditing, of course, is enabled and works for managed instance. And pretty soon you will be able, in managed instance, to connect your audit events to OMS, Event Hub, or Log Analytics. That is not quite flowing yet for managed instance. It is flowing already for Azure SQL DB. So when you go and configure SQL Audit, in the portal, as well as with PowerShell, you have an option to say, in addition to flowing my audit records into a storage account, I would also like to flow them to Log Analytics or Event Hub. And by doing so, this opens up a whole host of new possibilities that we'll be talking about in a little bit later on this afternoon. And then SQL vulnerability, again, nothing sort of new here. I think the good news is it works for managed instance. In fact, the team in Israel has updated the rule set there, so there is additional rules that are available that specifically apply to managed instance. So things like, and again, due to the enhanced or the enlarged surface area, there's rules that test whether or not you have enabled CLR, for example, what type of jobs you're running, again, what principals and users you have. So there's an additional rule set. So let me just quickly show you. Actually, let me stay in the VM for a second here. And
just let's switch to the laptop.
Oh, sorry. Yep. Forgot I was. Here we go. We're back on our machine. Let me just show you quickly the VA tool, and just we can quickly just look at. So it's under Advanced Threat Protection. There may be a few changes to that name, so we haven't settled yet on a name. And so if you come here, you will see that at this point in the portal, you have the ability to turn this on and off, as you know. And then in this case, let's turn threat protection on, and then we can set alerts here and email send email alerts to different folks. I'll leave that now, and then there's a storage account that you'll have to configure. So I just want to walk you through one here. So we'll just pick one. And okay, and so this storage account is used not only for VA, but it's also used for threat detection and so forth. So now we'll save this. Okay, and with that, we can now browse to a particular database in my managed instance. So we've got a whole bunch of them. I'll just pick one here. And at this level now, if you come down to Advanced Threat Protection, we're at the database level now, we will see the familiar dashboard that you may have already been familiar with from previous experiences. And so here, oops, I'm clicking on this now. So this is what it's doing. It's I need to actually why? I thought I had configured the storage account already. Let me go and double check. Okay. On threat detection.
How do we connect data sync with managed instance?
The Azure Data Sync, it's not available yet because it's a public service. Till you have the public endpoint, you will not be able to connect. Yes. Yeah. So just wait for the public endpoint capability and then you'll be able to connect.
Okay. All right, so I'm pretty sure I've configured this storage account here. So let me double check again and see what we get. Okay, we'll go to worldwide importers. I see, needs another storage account. So these are a couple things that probably have to get ironed out here a little bit. Sorry about that. We don't need this, we're good here. We'll just save this. Okay. And so now we'll scan. Okay, so this is a rules engine, as you know. It's running a whole bunch of rule checks against the configuration of the managed instance and this worldwide importers database. And with that, hopefully we'll get a report here in a few minutes or even a few seconds. And I think in the interest of time, I want to leave a few minutes for questions at the end, and I also want to give Ajay time to quickly show a TDE migration demo. We're going to let the scan run here, and then at the end, here we go. We can come back to that and walk through the different results. Okay, so here we go. So right away, one of the things that's a little different is you see there's a whole lot more rules than if you use this against SQL DB. I think we have about 60 or 70 rules now. So we have a few more here. And so other than that, the dashboard is very similar. In this case, we're looking at 15 failed rules. And so here are different types of failures or potential threads. And let me see if I can find any that are specific to a managed instance. I saw one with CLR earlier. So I think I don't see anything specific to managed instance right here. So I'll leave you with this, and I'm going to hand it over to Ajay, and then if time permits, at the end, we can also do a little threat detection demo. Yes?
Yeah, so if we have this turned on in multiple databases, will it roll up to Azure Security Center for a sort of a centralized view across all my instances and DBs?
Yeah, so question is, will this, once it's enabled for multiple databases, where is this going to roll up to? So you may have seen a blog from Ronit a couple of weeks ago. So there are now scripts available that allow you to do VA at scale across your instance. And those scripts don't roll up to Security Center yet. But the plan is, and it's in the works, that Security Center is going to be that dashboard where all the security alerts and reports are going to flow to. It already works for threat detection. For the VA scanner, not yet. So the tool basically gives you the ability to run the scan against a number of databases, and then it gives you the ability to collect all the results either in a spreadsheet or in a big JSON file, and eventually that'll flow to manage to Azure Security Center.
So on the Azure SQL, the transparent data encryption is enabled by default, but the managed instance is not?
Not yet. So again, that's one of those things, and Ajay may say a few more words here. That's coming right now. We have it available. You can turn it on. You can. We have service managed keys available. Very, very shortly after Ignite, there'll be the user managed keys. We'll do a little more testing on it, and then we'll turn this on by default too. But that's a good segue, actually. So Ajay, take it away on TDE.
Okay, so when it comes to information protection, we have different types of encryption, which is data at rest, which is provided by TDE, as well as always encrypted. We have data in motion encryption using TLS, and then client-side encryption with always encrypted, and actually all the three layers. So one of the challenges with TDE is a lot of customers have their own certificates. And if a database is encrypted with a certificate that you created on premises, how will you migrate and restore that database? Because you first need to move that certificate to managed instance and then be able to restore it. Otherwise, restore will fail. This is also true on premises. If you're moving the same database from one instance of SQL to another instance, you need to make sure that certificate resides. So with Azure Single Database, we have the capability to upload your certificate to Azure Key Vault and use that to manage and restore your databases. For managed instance, that is not available yet, but we have provided mechanisms where you can upload your certificate so that you can migrate your databases which are encrypted. And let me quickly show you that. So these are the different options I spoke to you about. Let's skip this. So service managed keys is what we support. So when once you upload the certificate to managed instance, we will convert it to a service managed key. After that, the database is managed automatically. If you want user managed keys or customer managed keys, that's not there yet. So the Key Vault support will come in the future. So let's look at how you do a restore, and then we'll go back to threat detection. Okay, so here I'm connected to an on-premise SQL Server 2012 instance, and you can see I'm going to use the AdventureWorks 2012 database. So I already have a server certificate, which is encrypted by password, and then I have a database encryption key, which I created, and it is protected by that server certificate. The next thing I did was I turned on encryption for my database, and if you look at the settings, you can see the database is encrypted by a certificate called TD demo cert for IG. Now, to be able to restore this database, actually before I do that, let me show you. I then backed up the certificate to a file, and this is a certificate we will need to upload to the managed instance. So before I upload it, I need to back up my database also. So I have created a credential to my blob store where I'll be uploading the database. Most of you must know that backup and restore support backing up to a blob store directly. So this was introduced with SQL Server 2012. So you can create a storage container where you want to back up your destination to, and then you need to create a credential on your source instance so that the source instance has permissions to write to that storage account. So which is what this command does. So I create credential, and then I need to give it a SAS token. So once you create the storage account, you can go get your SAS key for that storage account. Think of it like the permissions to write to that account. So here I pass it to that. And now this credential has been created on my source instance, which will then allow me to successfully back up my database to URL. So the only new syntax here is Instead of 2 disk or a network share, you have 2 URL and with credential. Everything else is your regular backup statement. And once the backup finishes, if you go to the portal to your storage container, you can see that my database is here. It's backed up. It is encrypted with TDE as we saw earlier. So let's go back and try to do a restore on managed instance. So to do that, the managed instance needs to have access to the same storage container so it can read that backup file and restore it. So I have created the credential on an identical credential on the managed instance with the same permissions, secret. And now, before I restore, I want to just quickly see to make sure you can do a restore file list. It'll tell you if it can read the backup and its contents. So let me go and run restore file list on my backup. And as you can see, the error you get is cannot find server certificate. What this tells us is managed instance saw that this was an encrypted backup, but to open the backup, it needs the certificate, and the certificate is not there in managed instance. So if you are uploading a TDE backup, you will see this when you try to restore. So the solution to fix this is to first upload the certificate there. So to do that, we have again a free sample in the PowerShell. This goes and uses the APIs to go and convert your certificate to a PFK file, upload it using an ARM API to the managed instance, and then you will be able to restore. So let's go ahead and run this script. All I need to provide is my subscription, the managed instance where I'm uploading it to, and the location of the certificate files on my disk, which I need to upload. So if I go ahead and run that. In the managed instance. So Azure Key Vault support will come later. So right now it's just registered as a service managed key managed by managed instance. So you can see that we are loading the file, and then now we're adding the TD certificate to the managed instance. So now let's go and run the restore file list only command again. So now since the certificate is there, this command should be able to see the contents of the backup and tell us what files are there in the backup. Let me make sure I use the right. Let me make sure I use the right backup.
Yeah, it looks like the backup is not created with these keys.
Okay, so let me do the backup again with this right certificate. I was trying it a few times, so I may have changed the certificate. So now I repeated this. So let's try the restore. Okay, for some reason this is not working, but if the certificate was properly restored, you will be able to restore your database successfully. Yeah. So in the interest of time, I'll pass it back to you.
Okay.
And then we'll.
So thank you, Ajay. A couple things on this. So this, of course, is a great way to get your database into managed instance. It also illustrates one of the differences between SQL DB singletons and managed instance, because as you probably know, this does not work with a singleton DB. There's no way we allow you to take a backup and then restore that into Azure SQL DB if you use singletons or elastic pools. And that's, of course, for security reasons, because of the fact that that's a multi-tenancy system versus, as Sergeant was explaining, managed instance, you have a virtual cluster that you own that is sandboxed, that has all kinds of security around it. And so we can allow you to take your own backups, put them there. If you're okay with that, we're okay with that. Not in the other model. One more thing here, we have a service, a migration service, data migration service, DMS, that will do the same thing. Ajay was illustrating, I think what's really useful, what he was doing is to illustrate what happens behind the scenes, because he could have just turned on DMS, a few clicks, the thing would have been backed up and restored. The certificates all go seamlessly under the covers. You don't see anything. But DMS under the cover, of course, uses backup restore, and it uses those APIs, those crypto APIs for uploading the keys. So that was the whole purpose of this demo, is to show you not only this is one way you can do it, but this is what happens underneath the covers if you next time choose to use DMS. So we're almost done. Let me just quickly go back and show you the threat detection part. And for that, I'm actually, sorry. I'm going to go to my portal here, and a little bit slow. I'm going to jump to that managed instance that we were looking at. Okay, it's a slightly different one. I have already threat detection configured there. I don't want to waste time. And so if we look at, for example, AdventureWorks database here, and now look at threat protection, what I wanted to show is, here we go. So we played around with this a couple times, and so as you can see over on this side, in the portal, you will get notified if there's an alert. Let's say there was an injection attack. And by the way, I should explain, threat detection is getting enhanced. The team in Israel is working continuously to add new algorithms. So the latest is we detect injection attacks, exfiltration attempts, meaning data that's flowing out that shouldn't go out, password brute forcing, unknown IP addresses connecting. So there's continuously new innovation here that's coming. And so alerts go into two places. They either go into an email that you choose that you can configure in the portal, and they will, excuse me, they will also go into the portal, and from the portal, they will also, these alerts also flow to Azure Security Center. So just one last quick overview. So here we are looking at the security alerts that were coming against the AdventureWorks database. And then if you were to click here, you can get more and more details. Some of the stuff gets pulled out of auditing, of course. Threat detection works hand in hand with SQL auditing. You don't have to turn on auditing, but it's highly recommended, because if you have audits, in addition to the threat alerts, you'll see information like the attacked resources here. And further down, you can also see, bless you, what type of attack was happening. In this case, it was an injection attack, and so forth. So let me pause here. We want to have a couple minutes left over for questions from you. All the material will go to you, of course, and we'll put the GitHub information in there. Yeah, I think, as you can see, a little bit of stuff is still work in progress. Security is important to us. We have a big team working on it. Things are complicated in some ways. We have scripts that we will make available to you. So that's it from our side. So I'll open it up to some questions from you guys still. Okay, so here and in the back. Hold on. We'll just go to the person in the back first, and then we'll come to you.
Yes. So if you're already bringing an encrypted database?
No. If you were just bringing an unencrypted database to manage the instance, wouldn't it be encrypted by default?
Not today. So today it's not, yeah.
Not today yet. What you could do, though, is if you turn on TDE encryption, that's controlled at the server level or at the instance level. So before you migrate, if you turn on encryption at the instance level and then migrate, it'll stay encrypted there.
Yeah.
What if you just unencrypt the database before you import it, before you migrate it to the service, and then re-encrypt it?
Yeah, if you're okay with a service managed key, you can do that. So you can use SQL Server manage the key for you and encrypt it there. You can do that too.
Yeah, absolutely.
What would be the need? Why would you want to keep your present key? If you're gonna
So one of the most common reasons is it's a trust, right? Since it's a public cloud or a hosted environment, customers or business applications want to manage their own keys so that there is no attack from an untrusted party or resource, right? So only the owner of the key can unlock the database. So that's the main thing.
that's the reason to import the key that's already there because they want to control the key and not.
Correct.
And one more from my side to add to this. In general, I think, and customers know this and do this, when you migrate anything that has anything sensitive in there, it's good to keep the encryption. So most customers actually don't feel like I want to decrypt my database and then migrate it and then encrypt it. It's much better to keep it encrypted because you never know where it lands along the way. And so we, for example, encourage you, if you use always encrypted, for example, we want you to leave your columns always encrypted, migrate it into the cloud with the encryption on, both TDE and always encrypted, so that nothing happens along the way. So that's really the preferred way to do that kind of workflow. Good question, though. Yes, you had one?
Because this is the managed instance, will it be possible that we can use the on-prem HSN?
Not yet. So you can use an on-prem HSN to generate the key that the gentleman was talking about earlier that you used to do TDE encryption, and then we'll allow you to import that key into an AKV Azure Key Vault that's coming very soon. We have not.
What if I don't want to, you are okay, but I would like to use my on-prem?
Yes. So we've been talking about this. It's something that we're discussing right now. There are a few challenges by allowing you to connect on-prem to an HSM. Who's responsible for managing connection? What if the network is down? There's a few things we want to work out carefully before we allow this scenario, but this is definitely something that we're looking at.
Yeah, and since decryption and encryption also happens for applications during query execution, if the SQL Server cannot talk to the HSM, your application will go down.
So there's a lot of responsibility there. If we take that on, then customers will likely come to us quickly and say, hey, my database is down, you figure it out, and then we'll have to troubleshoot the whole thing and figure, oh, maybe it's because the HSN was not available. Not to say that it's not at all a feasibility, but we're looking at it right now. Yes?
How about versions? If I have an older version of SQL running and I have an upgraded database, how's that handled?
So as you saw here, right, the database we use is 2012. So this is just, the behavior is just like what you see on-premise today. You can take a backup of SQL 2008 and restore it to 2016 and 17. The database engine upgrades the internal version, but it retains the original compat level. So from a functional correctness, your application will continue to run on the same compat level as what you had in the source, right? And you can, of course, change the compat to the latest level if you want to leverage the latest benefits.
You actually have that control. If you use the data migration service, as part of the workflow, it'll ask you, would you like to retain the current compat level, or do you want to change anything because SQL DB now in the cloud we're at compat level 150, for example. So you can control that carefully there. Okay, with no further questions, thank you for your attention. Hope this was useful, and feel free to reach out to us and our colleagues. We're excited to help you out and make sure that you have a good experience there.
Thank you.